Bene. Welcome everybody to a new seminar of Build the Future. Build the Future is a series of presentations that show how research can address all the problems our society is facing. Today we are broadcasting from Labora, which is a physical virtual laboratory modeling here at our School of Architecture. I am Gianluca Valenti, and once again, I welcome all of you to today's seminar dedicated to mobility poverty, which will be given by professors Valeria Fedeli and Simone Vantini, who share a very different background, but they share the same goal. Before welcoming on the floor our speakers, I would like to say a couple of rules for how we are going to manage the presentation. The presentation itself will last about 30 minutes. We kindly ask you to please keep webcams and microphones off during the presentation. If you have questions, please write them in the chat box so that we can take them out and there share them with the speakers during the Q&A session. Lastly, during the presentation, we are going to have 3 polls, and you are invited to reply to these polls hooking on the internet at the address shown on the slide, which is www.wooklab.com/safariniema. Please take a note of the address which we're going to use for the post. Now I welcome on the floor Valeria. Valeria, it's all yours.
Thank you very much, and welcome also from my side to this webinar. Together with my colleague, we will try to introduce you to some general hypotheses related to a recent research project we developed together with other colleagues here at Polytechnic. We selected this project because we think it's very exemplary. It makes it very clear how we try to address our role in the future of research and in the future of society. So basically, we can start, and I would like to have a short warm-up introducing you to a sort of a very simple pool. How much do you know about the Sustainable Development Goals? Please try to give an honest answer and clarify to me what do you know about the SDGs. The poll is started and you can reply. Answers are arriving, don't be shy. At the moment I have just one answer, not really. Just one, make your best to contribute. More balanced, yes, not really. Let's see if someone else is going to reply. Come on, don't be shy. Okay, 5, 6. Okay, just from this answer, I got that some of you know something about SDGs and some others not really. So it's important to remind that SDGs, Sustainable Development Goals, have been launched some years ago by the United Nations in order to agree on a common agenda for sustainable development. So the question today is, the issue today is not about debating in general, in theory, but trying to address more in depth one of the Sustainable Development Goals objectives. And the objective today will be, our focus today will be on mobility. So this is the second question for you. Do you know how much mobility is important in this general agenda for sustainable development? Try to, again, give an answer. Let's see if I can see the results. Not yet. Okay. Again, let's try again to see if the poll works. Anyway, if it works well, otherwise I will comment about the fact that mobility is really, really important in sustainable development. It's a very crucial issue. So, and if you go in depth in this sustainable development agenda, you will see that there is a specific target dedicated to ensuring to people everywhere in the world accessibility and the right to mobility. So let's start from this hypothesis that mobility is crucial. And there is a large part of the world where poverty and poverty related to mobility is a crucial challenge. Especially in the cities of the south of the world, this is a crucial element to address for policymakers and policy designers and for experts. Why? Because in contemporary world, the right to mobility is part of the right to the city. If you cannot move, you do not have resources, you do not have capability, you cannot access to your job or other very important resources for your well-being. This is very important all over the world, but in particular, there is a part of the world where the problem is more consistent. Equal access to mobility to all range of citizens is a key challenge for the cities of the south of the world, as we will see in a while. But despite all our efforts to produce and design policies able to support this kind of problem, policies which are also funded by very important international bodies, still mobility remains a huge and denied right for many people. In particular, people in cities like the one we will talk about, Maputo, but in the rest of Africa, have hard time in accessing private mobility, like cars. They cannot afford them, but they also cannot rely on public transportation. So they use this kind of buses in order to move around the city. These kind of buses are managed by private owners. They run on very unofficial and informal schedules, and their routes are not predefined. They can change their destination along the trip. What does it mean? You may imagine that this is not a safe way to move. This is not an efficient way to move. So safety, punctuality, reliability are not related to the standards we are used to in the global north or in the rest of the world. This is an example of a vehicle that is used in Maputo, and it's called My Love. Why? Because you have to hug all the other travel mates in order not to fall down from the vehicle. This is the official name in Maputo, but the literature normally call this kind of mobility paratransit mobility, and looks at paratransit mobility as a problem because it's chaotic, cannot be an efficient way to move in a big city or in large metropolis like Maputo or other metropolis of the developing world. What we did is try to reverse the perspective and think about paratransit mobility as a resource rather than a problem. What does it mean in terms of methodology and approach? All over the world, there is a growing awareness about the fact that you need to design policies on a place-based dimension. What does it mean? To work with people locally in order to develop ideas that work. However, too often, the solution that we propose as planners and experts are the result of a mainstreaming action from the north of the world, and this does not work. Sometimes we find innovative solutions developed for specific cities, like the bus rapid transportation system in Bogota. But these are quite exceptions because we normally look at cities when we are planners for what they are not and what they should be. This is unfair because it does produce a sort of unequal approach to all the cities in the world. So what is important? Cities have to be looked at with attention and care. Why? Because they are complex animal, complex social fabric. And moreover, they are unique and specific. So you cannot use the recipes developed somewhere else in order to address problems locally. And this means that if you want to leave no one behind, you have to really develop place-based developed approaches. I'm trying to conclude and also introduce my colleague, Simone Vantini. But just before that, I would like to remind you that we had a big chance, the chance to work in a city that was already open to such an approach, where other colleagues before us had tried to map in an analogic way mobility and paratransit mobility. So what we did when we arrived is thinking about the opportunity and possibility and potentials of big data to produce new digital mapping of these mobility offer and mobility practices, trying to build the basis and shape the basis for a new policy design approach. And before introducing Simone, there is another poll that we would like to launch. Think about what are the competencies that are needed in order to develop such an approach and address the issue of transport poverty. While you are voting, I'm passing to Simone and leaving the floor to him. Thanks for your attention.
My name is Simone Vantini. I'm part of the Safari Niema project. I'm still waiting for your comments about the competence needed to face this kind of problems. I see data, management, pragmatism, patience, logistics, right? Sociology, right? I can see a lot of disciplines here, and the answer is exactly this one, policy making and so on. A lot of different competencies are needed to face this kind of problems. Indeed, what we are doing here at Polytechnic is exactly to put together different competencies, try to solve this problem, proposing a multidisciplinary approach to the solution of this problem. Many of the questions raised by this kind of problems, the solution to these problems has exactly found an intersection between 2 or 3 different competence areas. Here I want just to report the competencies that we put into place to solve this kind of problem in Maputo. So we have 5 departments that have been involved in this research: the Department of Mathematics, the Department of Urban Studies. Valeria is indeed from the Department of Urban Studies, and I'm instead from the Department of Mathematics. I'm actually statisticians working as a data science at the MOS lab, which is the laboratory for modeling and computing of the Department of Mathematics of the Politecnico di Milano. We have also the Department of Management, the Department of Computer Sciences, and the Department of Designs involved in the research. And also other competencies that we put together coming from external actors. Here on the right of the slides, you can see different partners of the projects. On the top panel, we have the original partners of the projects. We have Cubic, which is a location data company, Vodafone, which is a mobile phone company, the University Eduardo Mondlane of Maputo, the Italian Agency for International Cooperation. Then we have also some local actors like the Metropolitan Agency of Transport in Maputo, a think tank from Maputo, WASA, the United Nations, and also other projects which partially share the aims of our research. I just wanted to mention 2 projects here, the project TSAM, which is coordinated by University College London, and another project, Digital Mathetos, which has been coordinated by the Massachusetts Institute of Technology. So as I have just told you, I am a mathematician, so I really love numbers. And I want to start this part of the presentation with 2 numbers. The first number I want to make you aware of is 80%. This number suggests to what extent transport poverty affects sub-Saharan population. In sub-Saharan countries, indeed, 80% of the populations has no access to safe, reliable, and cheap transport services. 80% of the population is poor in terms of mobility. However, 70% of the populations own smartphones. The idea of the Safari Nema project was indeed to try to put together these two facts, the huge penetration of smartphone technologies in sub-Saharan country with the huge amount of transport poverty in sub-Saharan country, and try to leverage the data generated by mobile phone to create proposed organizational solutions to transport poverty. So in the following parts of the talk, I will talk about some examples of applications. They are all based on 3 different data sources. The first one are the GPS location data provided by Cubic. I will dedicate a slide to it. Then we have the crowdsourced data from OpenStreetMaps. And then we have also satellite images. So I just want to go a little bit deeper in Cubic data because these data are kind of unique in this kind of geographical context. Cubic data are basically GPS location data collected through smartphone applications. It's basically a huge set of points in space and time. So for each mobile phone, we have a sequence of positions along time of the mobile phones. So thanks to these datasets, we have been able to track 20,000 people in the area of the greater Maputo. So the first step of the analysis was to move from single points to actual journeys. So as you can see in this simple picture, we try to identify origin, destinations, and also the trajectory that a single mobile phone, and so possibly user, has used to go from a given origin to a given destination. So the first example of application I want to mention you is exactly how, thanks to this data, it's possible to build the so-called origin destination matrices. Origin destination matrices are mathematical tools which is at the basis of the design of every mobility service in modern countries. So these are big matrices in which for each origin and for each destination, we simply count the number of people which have moved from origin A to destination B. Of course, it's simple to compute this matrix once you have identified the trajectories of the journeys. So you can compute, for instance, where the mobility demand is distributed, both with respect to origin and destination. And also you can find some very popular pairs of origin destinations. For that address on which pairs it could be useful to build mobility service able to support that demand. A second example of applications is the construction of the so-called user line matrices. What are user line matrices? Are once again matrices in which we try to capture the access of peoples to some given lines of transport, chapas in this case, which are the small minivans that Valeria just showed us. So here in this map, you can see 4 lines are the most popular 4 lines of chapas in Maputo. And basically what we did is for each journey estimated on cubic data, we were able to assess using also some automatic transfer mode detection algorithm if that journey has relied on a given chapas line or not. So from this kind of analysis, you can elicit some very useful information like the number of journey used made just using just 1 line, the number of journey that use 2 lines, 3 lines, 4, and so on lines. And the interesting fact here is that more than 50% of the journeys involve at least 2 lines. A connection, an interchange is something kind of painful in Maputo. You might have to wait between 15 and 45 minutes. So if I have to make 2 connections, I might lose 1 hour and a half on the way to work, for instance, and 1 hour and a half on the way back home. Okay, it means 3 hours a day spent just waiting for a bus to come. So this analysis could be made also more complicated. You can estimate for each single line, each pair, every triplets of lines, how many journeys, how many users are using that single line, that pair, and so on. And you can see here, for instance, that there are some triplets of lines which are very much used here. And you have to see at this kind of bar, like proportional to the time lost by people using that combinations. And some triplets are even more used than some single lines. It means that just changing the structure of the mobility service, we could save a lot of lost time to people. This is the third example I want to mention you. This is based on satellite images, actually. So when we started the project, the idea was to reorganize the lines, propose some tools that would be given to the Metropolitan Agency of Transport to reorganize the lines using the same physical assets that they have. And the first surprise was to identify that there was no trace about the quality of the road infrastructure. We didn't know if a line could go through a given road or not, because we didn't know if that road was paved and unpaved, and nobody knows that. So relying on OpenStreetMaps, which is nothing but the digitalized version of a road network, and some streets that you can see on the left, that have been, let's say, tagged by users as unpaved or paved. We built a machine learning algorithm able to estimate the probability that a given road, any road in Maputo, is paved and unpaved, such to be able to move from the left scenario to the right scenario, which is a scenario that could be useful to design mobility services. So here I want just to summarize the procedure. We started from raw satellite images. We make a segmentation analysis, taking the pixel associated to the street segments. We made an automatic cleaning of the image, removing objects like cars, vehicles, trees, building, and so on, keeping all the pixels which are possibly associated are just pictures of the street coverage. And then we model this pixel as a cloud of points in a three-dimensional space, the RG space, the typical, let's say, coding which we represent colors in computer sciences. Then looking for similarities between a data cloud associated to a street, for which the type of code is not known, and data clouds of streets in which the type of code is known, using a method which is kind of popular in machine learning, which is called the K nearest neighbors rule. We estimated the probability that an unknown street is paved or unpaved. The very last application I want to mention you is an accessibility analysis. Another very important issue in mobility is about the difficulty to reach public service from some given points in the city. So here the focus is on healthcare facilities. This is the Maputo Central Hospital, which is the largest hospital in Mozambique. And we wanted to estimate here, for any points in the city of the greater Maputo, how much time is needed to reach that hospital during the weekend, on peak hour, at noon, during the night, and so on. So it's something we can do with this data, with GPS data. Basically, we have the trajectories. We can, let's say, filter all the trajectories, having as destination the hospital. And then moving backward, we can estimate how many minutes before the subject that has reached the hospital was in a given location. So we can do this kind of analysis with all the trajectories heading to the hospital. And then using some partial regression methods, we can estimate the map on the right, which is a heat map representing the isochronous lines, which are all the lines associated to a given time needed to reach the hospital. You can identify, for instance, some areas here on the top left part of the panels, from which it's very difficult, for instance, to reach the central hospital of Maputo. So I'm going to conclude with these slides. So I show you 4 applications from the perspective of a data scientist, and lots of other competencies that were needed to make this kind of analysis. I want to mention here the data, of course, which are the foundation of this kind of work: urban studies, machine learning, statistics, computer sciences, design, and management. So this kind of the multidisciplinary research is common practice at Polytechnico. In Polytechnico, we have some research structure which move across different departments. Are multidisciplinary groups made of researchers from different departments. Valeria and myself are part of this group, which is called Data from Territory. It's exactly trying to leverage the information containing data to solve territorial problems. So this kind of the multidisciplinary approach is not just pursue the level of research, but also the level of teaching. All the applications I mentioned you are actually results of some Master of Science thesis of students here at Politecnico di Milano, in different degrees, of course. And of course, this kind of projects are related also to the social responsibility of our university. This project has been founded indeed by Politecnico di Milano. And I think we can conclude here. Thank you for your attention. Here you can see our contacts. You want to write us if you have questions or curiosity about this project or about Politecnico di Milano.
Okay, thanks everybody. Thanks in particular Simone and Valeria. We are now open for questions. Please, you can type your curiosity in the chat box so that we can pass it over to our speakers. Okay, we have question number 1, which goes, what was the impact of your research on the current local policies? So what is the effect locally of your research?
Okay, that's a very good question. Thanks for introducing this idea that what we study can also impact on the way in which public actors and administration in particular can tackle with problems. And as I mentioned at the beginning, the city of Maputo was already working to tackle mobility poverty. And I think what they realized, what they understood, is that this kind of analysis that Simone Vantini has just introduced to you can provide a portrait of the city, a portrait of mobility, but also a portrait of how people live in the city. Where are the poorest areas, for example? So on the one hand, a general picture that can be very important for developing a urban agenda in general. But they also realized, and they were ready to do this kind of effort, that this informal mobility or paratransit mobility could be much more integrated with the public and collective transportation system. And on the basis of the data we collected, they could have a sort of beginning of a new era in a certain sense, where public mobility could be integrated with collective mobility, making it much more efficient and sustainable a system of mobility for all the city. So you could not just get rid of this paratransit offer, but you can build, they could build on that a new, a more extended offer to different users all over the city. And I think this is a very important impact. And we tried after the end of the project to build future steps together with the Agenzia Metropolitana di Trasporte, which was particularly happy, I would say, to go in that direction and started new policy and projects to reinforce and to support collective mobility operated by private operators in order to go in this direction.
Okay, I think the next question follows up actually with the first one, and it talks about big data. So, Simone, I guess it's for you. So how simple it is to manage big data for the local authorities? how to pass this project over, continue on?
It's actually terribly difficult. It's difficult here in Europe. You can imagine how difficult it is in a country which is not used to manage this type of data. I have to say that to implement this kind of approach, we had the support of the University Eduardo Mondlane and all the students of that university, which are kind of skilled with respect to data scientists. Not the cubic data, but most of the OpenStreetMaps data have been collected by students of that university. Institutions are trying to familiarize with this type of data, of course. It's difficult, but I think that here there is a huge opportunity of take advantage of this data. Compare, for instance, to Europe, in which we have a very solid structure about how mobility is managed. And this shift towards data-driven mobility is happening, it will happen next year. Here we have the chance to complete this kind of approach from scratch, without any constraint coming from the previous history.
Much. While I read the third question, I remind everybody that if you have curiosities, please go on the chat box and type it in there. The third question is, how are you going to move on? So what is your NEMA 2.0? What is the next step?
Okay, I can start telling you the story of what we did already to go towards Safari NEMA 2.0. We work with the public administration locally in order to develop a project to be funded by other international bodies that work in international cooperation and support in developing countries, in order in particular to go in the direction that Simone was mentioning. Public administration had hard times to manage all this data, and moreover, they are to develop their own way to address the big actors that retain this data. So how to interact with big players and how to move from interaction with big players in order to develop protocols for collecting the data and managing data and using data to produce knowledge. So the first opportunity we had in this respect to move forward was to develop this kind of a new project, which was not necessarily based just on mobility, but on the general issue of how big data can become a very important and strategic asset for public administration, and how they can and they should develop expertise to use those data in an intelligent, smart, and open way to understand how cities are changing, what are the challenges, and go beyond a predefined idea what the problems are, and how, much more interesting, which are the solutions to problems. So we work in that direction, and this was our way to move forward. But of course, we try together in many other directions. I don't know if Simone wants to add on that.
I might add a comment on what you said, Valeria. Maputo was chosen as a pilot case, actually. But from the very beginning, the aim of Safari NEMA project was to propose a way of solving this kind of problems. So scalability was one of the constraints we imposed ourselves. And the idea was to build a solution that could be easily taken away from Maputo and applied to different cities. Mobility, as Valeria clearly shown, is a global problem. But if you look closer, the specific problems of mobility are very local. Each city is different from another one, each neighborhood is different from another neighborhood. Okay? So we want to build a flexible procedure, flexible way of working that could be successful not just in the pilot scenario of Maputo, but also in other metropolitan area of the world.
I think you have anticipated actually the answer to the next question, because the next question would be, is this project deployable to other cities, as you were saying, or is it there? Are there some specific consideration for each locality? So there's something, how deployable, how generalizable is it, or how specific is it?
Again, this is a question that goes back to the origin of our speech today. We are aware that first, every city deserves special attention. So you cannot expect to solve the problems locally without understanding with local people, actors of different kind, what kind of city you are working in. So here you can see a picture of Maputo. You can see the map of Maputo, where in the place where we are giving this webinar. This means that every solution has to be situated to work in a more effective way. At the same time, it's important to develop locally solutions that can be scalable or reproducible, can be reproduced somewhere else. Of course, this happened also for us. We try to work out solutions for sub-Saharan Africa, for example, and not just for Maputo, working with other international bodies in that direction. So it's a balance. You have to work locally, but at the same time thinking about the whole problem. And this provides you food for thought in a certain sense, opportunities to go in depth and at the same time think about the whole problem in a different way from different perspectives. And this is research, basically. And I would say we enjoyed very much this opportunity to be in one place, but at the same time understanding what are the challenges related to such kind of exploration and policy problems.
Okay.
I can.
Yes, definitely.
Related to these questions, most of the analysis of the method developed in Maputo have been used also here in Milan later on. During the first pandemic wave of COVID-19, for instance, we estimated the origin destination matrices in the Lombardia region to study how mobility was changing, and also the accessibility maps have been applied also in this scenario to assess how easy it was to a person to reach an healthcare facility during the pandemic wave. So scalability was kind of proven and turned out to be very useful also in countries like Italy.
Okay, be ready because there are a few other questions. Are you aware of other similar projects? Something, are you aware? Maybe not, maybe yes. Are there going to be interactions to maybe have a even wider outreach?
Yes, Simone mentioned one project that was already working not just in Maputo, but in other African cities. Kisam and Digital Matatus was even before us. So this makes it evident that the potential of big data in order to map people mobility today and address the problems of mobility of people in large metropolitan areas is on the agenda. So we try to meet and exchange with these other projects. And during our process of research, we met other colleagues that are doing the same kind of effort. So we are quite sure that this is promising, not just because we are, let's say, engaged in that, but because many other colleagues are working in that direction in different cities all over the world. Just think about that. Paratransit mobility is something that happens also in European cities. Think about Uber or other kind of mobilities. This is not public mobility. It's a form of individual collective mobility that has not usual routes, moves on individual way, destination and origins are different from the traditional ones. So we learned that informal mobility is developing all over the world. It has always been. So this is a huge hint on the promising aspects of this kind of approach, let's say, to the problem.
Okay, we have a question from somebody who already sees business in this. What are the challenges and the opportunities for the vehicle manufacturers to deploy their vehicle with some advanced coordination, some advanced features of this data that are going to be generated? So the vehicle and the manufacturer of the vehicle.
We should have the colleagues of the part of management to answer these questions. But the quality of vehicles is kind of a problem. in Maputo. You can see this picture, but I mean, the safety is also related to the quality of the road infrastructures and of the vehicles. It's a big issue. This is a funny story. This is often mentioned in Maputo by the Agenzia Metropolitana di Trasporto. So some years ago, they reserved let's say, collection of brand new super modern buses. And they started using those buses. But those buses got managed very soon because of the potholes in the roads. Okay, so they become kind of useless. So there is also technological aspects here, which is not just related to the vehicles, but also to the road infrastructures. And another fact that we like to have seen in Maputo and was kind of a problem for us was that we didn't have GPS data about the vehicles that could be terribly useful to that mobility. We were able to map users, but not vehicles.
Okay. Okay. There's a technical curiosity. I think, Simone, this is going to be for you. Which software is used for the analysis? And did you involve directly the students of Maputo University?
So most of the analysis have been done using the software, the open source software R, that together with Python is one of the more popular programming languages in data science. Some small routines have been done using C++, where a larger computational power was needed. And we involved, yes, the students of the Mondlane University, at least in two phases, I would say. When we were down in Maputo, also, we put together some students from the Mondlane University together with some students of the Politecnico di Milano. They participated in this Mapathon, which is a collective operations related to mapping the bus stops and the lines. And it's thanks to them they were able to make, for instance, the second analysis, in which made the intersection between Chiapas lines and trajectories. And then we also gave a course, a 1-week course. Unfortunately, it was remote, but was during the pandemic in Maputo, in which it was a 5-day course, not only for students, but also for people working in mobility in general in Maputo. During the day, we talk like teachers, but during the afternoon, there was some interactive parts with the students, and the students developed some projects using some very local knowledge that was not available for us. For instance, it was terribly useful.
Okay, there's another question on the data. So what are the merits and the limitations of the data? What are the merits, the pros and the cons of the data sources, the cell phones? And what are your suggestions on how to improve the collection of these data? So what could be done to get better data?
Okay. I could mention 2 data sources here that we use in the project. One was not mentioned, applications here, but is there. So on the one hand, we have GPS location data provided by Cubic, the data for the department of Cubic. And on the other hand, we have some traditional mobile phone data provided for free to the project by Vodacom, which is the Mozambican branch of Vodafone. So cubic data are, for a statistician, data science are terribly amazing because the spatial resolution of this data is terribly high. So we are able to locate a mobile phone with an error sometimes that is at most 1 or 2 meters. So it's really useful to understand if a person is waiting for a Chiapas and the bus stop is going to Chiapas and so on. These data are collected from users that opted in to share the data with Cubic, of course. And it was an interesting experiment because the business area of Cubic is the United States, is not sub-Saharan countries. And these data are collected through mobile apps. So in that country, we don't have popular apps in Mozambique are not the same popular apps we have in the States, for instance. So we have a problem that we try to solve making data integration with the mobile phone data. That is a social bias of the data. We might expect that those apps were not uniformly spread across all the segments of the populations. We see, looking at raw data, a lot of activities, for instance, around the University of Mozambique, where the population is younger and more keen towards technology, for instance, much less data in rural areas, even though in that area there are still a lot of people living there. So we try to make this kind of the biasing with Vodacom data. Vodacom data are traditional mobile phone data. The spatial resolution is poor. We just know if a mobile phone is connected to an antenna. We do not know the exact location of a mobile phone, so the error might be up to some kilometers. On the other hand, they don't have social biases. As I told you at the very beginning of my parts, the penetration of smartphones in the population is very huge across all segments. So there are pros and cons in data sources. One of the issues here was make what we call data integration, data fusion, such to take advantage of all the positive aspects of different data sources, such to build a new data frame that could take the best of both or from all data sources.
Okay, thanks very much. This methodology was applied to Chiapas. Would it be possible to integrate it with other kinds of transportations? You mentioned buses, maybe trains. How is it possible?
Okay. So this question related to a very important problem, which is transport mode, the identification of transport mode. Neither GPS data nor mobile phone data tells you if a person is moving by foot, is on a car, on a Chiapas, on a big bus, which are called machibombo in Maputo, on a private car, or on a small chapita, which are kind of three-wheels motorbikes. So we are trying, and we are still working. We have a master thesis going on in this issue, trying to focus on this issue. Develop machine learning algorithm, having to assess step by step which is the transport mode, the type of vehicle is being used by that user in that instant. So the first problem is this one. You have to filter the data if you want to understand if a person is on a Chiapas or on a machibombo, which is the big bus. You have to first understand if he's on a vehicle. Then you can understand that using some features which have been studied in the literature, like the acceleration of the path, the frequency of changing of directions of the journey. If we had a larger penetration, that was not the case. You could see if there are other guys which are moving kind of in a simultaneous fashion with that guy. You could infer that all these people are in the same vehicles. Okay. So technically is yes, but there is a problem that still have to be solved, which is finding a ways to have a reliable estimates on the actual type of vehicle in which the single mobile phone is moving.
Okay, thanks very much. And I think we're moving towards the last question. And if I'm a student interested in working on this topic, what could I do? And I would say both from a urban perspective and a data perspective.
If the question is related to how to get engaged.
Yes, I think, yes, I would interpret it like that.
I think we would both, and all the colleagues would appreciate students that are ready to take action and be a member of research teams that like the one we founded in order to promote this project. So on the one hand, here we have a tradition of involving students at different levels in our research. On the other side, I would say, as you have seen, we work together with different expertise. So maybe you are more passionate about the urban dimension, maybe you are more passionate with mathematics, but more and more working outside of these walls and in the city and society, we need to be together. So you can start taking action and be engaged in similar projects, even coming from very different disciplinary fields. But it's up to you and to us to provide spaces and rooms for such interdisciplinary challenges and enterprises. So we are looking for this kind of challenges. And if you are a student that is interested in such kind of challenges, take action, because there are many building sites in which we do research in this way, exchanging ideas, exchanging our language and competencies in order to address problems that are very complicated, but also very interesting and full of interesting things to do.
Yeah. I add small comments. We all believe that our students are terribly good students, so we are not afraid of involving students on this kind of projects. And there are a lot of opportunities during, let's say, the teaching experience of students at Polytechnicals getting involved in this project. Master thesis, we already mentioned them, but also we have a lot of team projects at Polytechnica. This is mathematics, for instance. Many projects have been done working on this data and on this problem. So you don't have to wait until the thesis, let's say, to work on real applications.
Okay, well, this was the last question. Valeria, Simone, thanks very much. Thanks very much for everybody for attending, and you don't see the people behind the organizers. Well, if you go on our internet website, you will see there are the recordings also from the past seminars of Build the Future. And I anticipate you that we are working on another seminar, which we will be communicated soon. And I spoiled another thing, that we're going to work on a new format of Build the Future, something that we call Build the Future 2.0, and this is going to be next. Thanks very much for everybody. Thanks very much to you.
Thank you.